Welcome to the Deep Dive. Today, you're taking a shortcut to being well-informed about one of history's most revolutionary breakthroughs, the early, simple microscope.
That's right. For this deep dive, we're really focusing on three things. The technical evolution of the instrument itself,
Okay.
the huge problems it solved, and then the profound impact it had on, well, all of human society. Before this, our knowledge was literally limited to what the naked eye could see.
So let's jump in. Where does this story even begin? I understand it starts almost by accident.
It does. You have to go back to the Netherlands, around 1590. Two spectacle makers, Hans and Zacharias Jansen, created a very early compound microscope.
It's a compound one, so that means multiple lenses stacked together.
Exactly. But it was pretty limited. Sources suggest it only reached about 10x magnification, and like you said, is an accidental side product of their main business, which was just making reading glasses.
So if that was the blurry accidental first draft, where did the real transformative leap happen?
For that, we go to the 17th century and Antonie van Leeuwenhoek. And this is where it gets really interesting. He wasn't a doctor. He wasn't a scholar.
What was he?
He was a cloth merchant. His whole motivation was commercial. He just needed a way to precisely assess the quality of threads in the fabrics he was selling.
Wait, hold on. So the breakthrough that revealed the microbial world came from a guy trying to be a better businessman.
Precisely. And his technique was the key. He didn't use those clunky compound microscopes. Leeuwenhoek made his own, over 500 of them. And they were all single-lens instruments.
A single lens. That seems counterintuitive, but that was the advantage.
It was a massive advantage. The problem with early compound microscopes was something called optical aberration. Every lens you add, it adds its own imperfections. It gets blurrier.
Ah, I see. So a single perfectly ground lens gave him a much clearer image.
Phenomenal clarity. He achieved magnification up to, well, sources say between 240 and 280x. That allowed him to solve the crucial problem of seeing what life is actually made of.
And that's where we start to see the discoveries roll in. Robert Hooke had already named cells back in 1665.
Where he had from looking at cork. But Leeuwenhoek in 1674 was the first to see living, moving organisms, bacteria and protozoa. He called them diertjes.
Which means little animals.
Little animals, exactly. And this observation starts to solve humanity's biggest health problem at the time. Total ignorance about where disease came from.
Right, because the dominant theory was miasma, the idea that disease was just caused by bad air.
And how could you argue with it? Cities smelled awful. But the microscope provided visible evidence. It showed that disease could be caused by tiny transmissible things, not just a bad smell.
So this laid the foundation for people like Pasteur and Koch and the whole germ theory of disease.
It did. And the technology immediately started to revolutionize medical diagnosis. Doctors could suddenly analyze blood smears, look for anemia, parasites like malaria.
And what about pathology? Looking at tissue.
A complete game changer. By 1886, they had lenses that could see details down to 200 nanometers. A doctor could look at a tissue sample and, by observing the cell structure, could tell you if a tumor was benign or malignant.
Wow. So let's zoom out. What did all this mean for society? It obviously proved that the cell is the basic unit of all life.
Yes, it forced this huge shift from a macro view of the world to a cellular one. But the impact went way beyond science. It really affected our entire worldview.
How so?
It promoted an empirical culture, the idea that you have to see the evidence, not just rely on tradition or ancient texts. It fostered a culture of rational thinking.
And that must have had practical consequences.
Massive ones. Understanding how microbes spread led directly to modern sanitation, clean water systems, and crucially, sterile surgery. Post-operative infections, which used to be a death sentence, just plummeted.
It's like it revealed an entire invisible universe that had been there all along.
It totally rearranged our perception of scale and our own place in the world. We realized we were sharing the planet with trillions of other life forms.
So a final thought for you to consider. Leeuwenhoek's journey, this whole revolution, it all began with a simple commercial need to check the quality of thread. In our world today, full of big data and complex tools, what small practical task might you be performing that could accidentally unlock the next fundamental scientific revolution? The biggest discoveries often hide in plain sight.